Today's lesson is going to be the synthesis of each of the days that we've talked about trigonometry. So in the past we've talked about SOHCAHTOA. Today we're applying both sine, cosine, and tangent. So it's basically in a lesson called All Mixed Up. Okay, so what we're going to do is we're going to actually solve these. We're going to have some sine, we're going to have some tangent, and some cosine problems. And it's going to start with simple, and it's going to move to more and more complex. There will be some story problems mixed in. There'll also be some triangles that you need to solve, maybe in a slightly different way than we've solved before in class. So let's take a look at this. The first one, I'll do a few of these and you will complete the rest of them. The first one, we see we have a fraction over here. Whenever we have a fraction, what we need to do is we need to somehow get rid of the fraction. The only way to get rid of a fraction is to multiply by the denominator. In this case, that denominator is 15. So if we multiply both sides by 15, we'll have 15 times the sine of 22 degrees will equal x. That'll just be whatever's left on this side. It's just x. If we put that into our calculator, we should get x equal to 5.62. The reason I rounded it this way is in the directions here, it did say to round to 2 decimal places. That means 2 places after your decimal. So that'll be our answer. Okay. The second one's going to be pretty similar, so I'm going to jump to the fourth one here. In the fourth one, we have something different. We have a k in the bottom. Okay. When we have a k in the bottom, we still follow the same rule over here. We need to multiply both sides by the denominator in order to get rid of it. What that'll give us is it'll give us k times the cosine of 6 degrees is going to equal 92. Now we can't put that into our calculator because it doesn't just say k equals something. Okay, so what we need to do is we need to actually divide both sides by the cosine of 6. So we'll have k equals 92 divided by the cosine of 6 degrees. We can put that in our calculator. And when we do, and we round it to 2 decimal places, we'll get k equal to 92.51. Okay, make sure that you're able to do these. Number 3 should be like number 4, and number 2 should just be like number 1. The next thing we're working on, if we look down a little ways, it says find the length of each side labeled x, round to now 1 decimal place. So what you have to get comfortable with is reading the directions. Not always rounding to 4 decimal places, not always just rounding to 2 decimal places. So it might switch 1, 2, 3, 4 decimal places. Depends on what it asks for. Sometimes it'll just say to the closest foot as well. At 35 degrees, what I need to do is I need to identify each of my lengths. This is my hypotenuse, this is my opposite side, this is my adjacent side. What 2 pieces am I given? I'm given my opposite side and my hypotenuse. Which trig function deals with opposite and hypotenuse? Well, hopefully you remembered that the phrase SOHCAHTOA, in this case, SO deals with opposite and hypotenuse, and it's pointing towards the sine function. So that means I'm going to say the sine, and then what's my degree? Well, the only degrees I have are 35 degrees. So the sine of 35 equals, it's always the opposite over the hypotenuse, so in this case this is x over 10. This takes us to the place that we had with problems 1 through 4, is that all we have to do is cross multiply, always multiply by whatever's in the denominator. So that'd be 10 times the sine of 35 degrees, and that should equal x. Okay. In this case, when we put this into our calculator, we would get x equal to 16.1 inches when we round to the nearest tenth. Okay. I think it's really important here to have the inches. The inches are really what's telling us how long this length is. That this is this long. I'm not sure if I put that in my calculator correctly. Let's cross that one out. Let's try that one again. It's 10 times the sine of 35 degrees. Oh yeah, that's only going to be 5.7 inches. So 5.7 inches is what x equals. Okay. One reason I knew my answer was wrong, and this is sometimes helpful for you to see, is that this is my hypotenuse. This is 10. Your hypotenuse is always the longest side of your triangle. So when I got an answer of 16.1, that kind of threw me for a loop for a little while. So this is a learning process for me too. Is that if I get 16, sometimes it's valuable for me to realize, well, that answer doesn't make sense. My answer had to be less than 10. Let's take a quick look at number 2. Number 2, if I label my sides, this is my opposite side, this is my hypotenuse, this is my adjacent side down here. Okay, so opposite, hypotenuse, and adjacent. In this case, I'm dealing with an adjacent and hypotenuse. So I try saying, what trig function deals with both adjacent and hypotenuse? The reason I'm looking at just these two functions is because those are the only ones I have values for. I know that my adjacent side equals x, my hypotenuse equals 35 meters. I don't know anything about my opposite side. So if you remember, one of our trig pieces that we should remember is ka, so ka toa, and that stands for the cosine is equal to the adjacent over the hypotenuse. So we'll say cosine of 54 degrees is going to equal, let's see, my adjacent side is going to be x over 35. Once I have this set up, I'll again just multiply by my denominator. That means that I'll have 35 times the cosine of 54 degrees is going to equal x. When I put this in my calculator, I'll simply have x equal to, let's see if I can get it right this time. I'll double check my answer. I got 20.6. And what are the units? Okay, the only units that are told here are m, which I think stands for meters. And this will be our final answer. You'll be able to do 7 through 12 on your own. You just need to basically identify from the angle what are each of the sides. And then secondly, say, well, if I'm given my adjacent side and my hypotenuse, what trig function is that? It means you really need to remember SOHCAHTOA. Let's jump down to number 13. It says find the required length. It says round to 1 decimal place. So that's 1 place after the decimal is how you would interpret that. It gives you a story problem. We'll look at number 13. When a 20-foot ladder, okay, so this dotted line must represent the ladder, is leaned against a wall, it makes a 72-degree angle with the ground. So that's this angle down here represented right there, 72 degrees. How high is the wall? How high up on the wall does the ladder reach? So really what we're trying to do is we're trying to calculate this height right here. And we're going to calculate that in feet. So again, if this is 72 degrees, this is going to be my opposite side over here, the x. This is going to be my hypotenuse over here. So I ask which trig function deals with both opposite and hypotenuse. Opposite and hypotenuse, that sounds like so to me, the opposite and the hypotenuse. So I know that I'm using the sine function. So I always say what's the sine of, well, the only thing that I have degrees of is 72 degrees. So I'll say sine of 72 equals my opposite, which is x, over my hypotenuse, which is 20. And that's setting up my equation. I'll multiply both sides by the denominator. That'll be 20 times the sine of 72 degrees. And that'll equal x. When I put this in my calculator, let me see if I can do this correctly. I'll actually get 19.0 feet. Okay, so this ladder actually extends 19.0 feet. I'm not sure if you really need the 0 here. It does say to round to 1 decimal place. I'd say if you had 19, I think you'd be fine. If you just had 19.0, I don't think that's a big deal either. It just gets you in the habit of putting 1 decimal place there. I don't think that's too bad. The next two, again, here's the degree. It has to be tucked in there because it's kind of too small to write. In this one, we're given a height of 100 feet, and this is our angle. We want to figure out how long this the cable would be to the top of that tower. If you flip over to the back sheet, this is going to be a little bit different. I'm going to skip 16 and 17 because they seem very similar to there's just not a story with the problem. It says use the figure to complete each statement. Okay, so we're going to use this figure at the right, and what's going to happen is things are going to alternate based on what the problem is. So write each ratio as a fully simplified fraction and then round to 4 decimal places. So that sounds familiar to us. It tells us that the measure of angle B is 65 degrees. So let me write that. This angle right up here, this is 65 degrees. Okay. From this angle, angle B, this is my hypotenuse, this is my opposite side, this is my adjacent side. Okay, so I've identified my 3 sides. I really think it's important to do this each time. If you abbreviate it with one letter, that's fine. If you write OPP, HYP, and ADJ, I don't think that's a big deal either, as long as you're identifying each of the sides. Okay, then it's saying then B over C equals what? So if I'm dealing with B and I'm dealing with C, that sounds like it's my opposite and hypotenuse again. That sounds like I'm dealing with sine. So again, this is going to be my opposite over hypotenuse, so I'm going to be dealing with the sine of 65 degrees, right, like that. So what it wants me to do is this is going to be the B over C is going to be my opposite over hypotenuse. That's how I knew it was sine. And how did I know it was 65? Well, that's what it tells me up here. So the sine of 65 looks just like that. What I need to do then is use my calculator to actually calculate what the sine of 65 is. And it is a decimal. That'd be 0.9063. Okay, 0.9063. At this point, I'm done with this problem, so I can kind of actually reset what I've been doing. So let me see if I can erase this a little bit, if I can figure out how to erase. Magic pen, here's some pens, no. Calligraphy, no. Creative, no. Magic, oh, here's an eraser. Let's just pick, let's pick this guy. I'm just going to erase this information up here because I have a new triangle that I'm going to deal with. Let me go back to the pens. Maybe I'll pick a different color. So for this problem, it's a new problem. I kind of just need to erase whatever's going on up here. It still gives me the measure of angle B. So I'll label that up here. The measure of angle B is 75 degrees. From there, I know, again, because of this angle, this is my adjacent side, this is my opposite side, this is my hypotenuse up here. So I identify which sides are what. And then again, I'm looking at B over A this time. So I'm looking at B over A. So I'm looking at which trig function deals with opposite and adjacent. In this case, hopefully I remember opposite and adjacent. Well, that's got to be TOA because it has the opposite and adjacent in it. So that means I'm going to be working with the tangent function. Okay, so tangent of how many degrees? Is it tangent of 65 degrees? Well, no, look at our triangle. We're dealing with a tangent of 75 degrees. So make sure that you're using the proper degrees. You can either get it from over here, or you can look at your triangle. If you wrote it over there, it should be there. Then just put that in your calculator. Remember, the funny thing about tangent is that sometimes it's not less than 1. In this case, the tangent of 75 degrees is actually 3.7321. Okay, when we round this properly, 3.7321. And that's what I'm really looking for, is that you're actually able to identify, well, from B being 75 degrees, this is this, identify your three sides as opposite, adjacent, and hypotenuse. And then based on what they tell you, B over C, say, well, okay, that's my opposite, that's my adjacent. So what I'm looking for is some trig function that deals with opposite and adjacent. That's TOA, so I'm using the tangent function, tangent of 75 degrees, and use your calculator for it. It's several steps, but I think that you guys can do this. Okay, if you review, I do want you to complete numbers 1 through 24 for this. Just take your time with this. There's a few story problems. You can use mine as a model. I think that if you're able to do problems like 5 and 6, that'll be really, really good for you for the test. It really tests you a little bit to make sure that you remember, okay, if I'm given opposite and hypotenuse, which trig function is that? In this case, if I'm given adjacent and hypotenuse, I got to remember, oh yeah, that's ca, so that's cosine. And these are always good practice just to make sure that you know how to work your algebra. Remember, you always multiply by whatever the denominator is in order to get rid of your fraction. And sometimes if there's a variable in the denominator, it takes more than one step in order to solve till you get something that you can actually put in your calculator like this. Okay? If you guys ever have any questions, make sure to let me know. I'm always here to help you. Make sure to ask questions.